Good afternoon, everyone. This is Matt Kyle. I'm with Palo Alto Networks. I'm sitting here with my colleague, Warby Warburton. Today we're going to talk about Autoscaling, the Palo Alto Networks next generation firewall in Amazon Web Services. Throughout the presentation, feel free to pose questions in the question box within BrightTalk, and we'll answer the questions at the end of the webinar. Okay, so let's get started. Just a second here.
Hi, everyone. We had the wrong presentation loaded, so just give us a couple minutes. We'll get the correct one loaded, and we'll start. Thank you.
Again, folks, give us just a second. I can guarantee you that we won't take the full hour, so your patience is greatly appreciated. The presentation was the wrong one, so give us shortly. It will be there in just a minute. Okay, folks, the status bar says 80% done, so we should be with you shortly. Again, we apologize for this technical glitch. All right. Isn't it wonderful when technology works? So today's agenda for the Autoscaling the VM-Series next generation firewall in AWS will go a little bit like this. For those who don't know anything about Palo Alto Networks, we'll spend about 1 minute on who we are, and then we'll jump into the Autoscaling integration that we've announced. And we'll also talk a little bit about some of the other options for larger scale security in Amazon, and then we'll close for questions. Again, if you have questions, please pose them to the audience at hand. So let's continue moving forward. A little bit about Palo Alto Networks, publicly traded company on the New York Stock Exchange, founded in 2005, shipping product since 2007. Our value proposition is to safely enable applications and prevent known and unknown malware. We have roughly 3,400 customers and 3,800 employees, and are a global company. What we're going to talk about today is our next generation firewall that we have made available in Amazon Web Services. So historically, we began shipping product as a hardware appliance with a next generation firewall feature set that revolved around controlling applications as opposed to controlling ports, and then applying threat prevention and user-based control to those that traffic. We moved that entire security stack into AWS. We made it all available in AWS roughly 2 years ago. And the same value proposition that we profess on the physical network applies to Amazon. We are identifying and controlling the applications moving in and out of your Amazon deployment. We are protecting that traffic from advanced cyber threats, both known and unknown. And then the additional value proposition is that because the security is consistent across the physical network and in Amazon and can be managed centrally by Panorama, it allows customers to have a very consistent security posture when you move from physical network to the cloud and back again. Another key tenet that we bring to the table is the ability to automate the deployment of our firewall in Amazon, and you'll hear a little bit about that in today's presentation, and also to automate security policies. One of the challenges that we see in the cloud environments is security runs at a specific cadence, meaning they follow change control processes as new workloads are deployed, as policies are updated. It's a very structured process typically, and this is a security best practice. On the other side, you have cloud environments where they operate very rapidly, making changes and updates on a more rapid basis than security might be able to keep up with. So we have some automation features that allow policies to be dynamically updated so that as workloads are changing, the security team does not necessarily need to go through a full change control process to update the policy. They can automate the policy update process to a certain extent, allowing security to keep pace with the business. Now, moving forward, the VM-Series in AWS, the progression that customers typically go through as they begin their deployment in AWS is a hybrid cloud where they're establishing a VPN connection from their corporate data center into Amazon. Common example of how that might play out would be moving your application development, testing, and production environments into Amazon so that you have greater flexibility for resource access, and you can scale up and scale down as needed. So that's how you might get started. You might move into a segmentation deployment use case where you're separating different workloads from the data or separating the users from, segmenting the users from accessing different environments. That might be an example of where you're getting a little bit more advanced. And then Internet Gateway, many customers are looking to move some of their public-facing applications into Amazon. And in that scenario, you would use the VM-Series to execute perimeter gateway type policies, all of which is managed centrally by Panorama. Now, as you move forward, I'm going to hand it off to my colleague, Warby Warburton, who's going to talk a little bit about how we can address autoscaling, the need to scale security as your workload traffic increases. Warby?
Thank you, Matt. So I want to talk a little bit about what autoscaling is, what it looks like. At a very high level, autoscaling in the public cloud is all about spinning up compute to handle requests for an application, for a security appliance, whatever it may be, in near real time. So monitoring and adding when needed. It also means removing when not needed. What this does is it lets you benefit not only let you leverage not only the benefit of public cloud where you're getting new compute, new resources when you need them, but you're also removing them when you're not needing them, not requiring them, so that you can reduce your costs during non-peak times. So in the case of AWS, there are a lot of native services that we can leverage to take advantage of autoscaling and to implement it with our integration. Autoscaling in AWS is kind of built around the elastic load balancing service. And the ELB is very easy to deploy. It's natively integrated, so it leverages all these other services to create a true autoscaling solution. So we need to be able to integrate with that as well. And we want to do it in a way where we're not in an environment where new application servers can be spun up in minutes, but it takes hours or days for the firewall to be added. We want to be added at the same rate so that we're not interrupting that process. So there's kind of an opposing force here with the scaling challenges where, you know, we want to be able to protect against cyber attacks. We want to be able to do it in a very robust way, but we want to be able to scale quickly. And so the nice thing about public cloud and having a virtual firewall platform is we can actually achieve both goals. And we'll show you in a few slides here how that's done. So in the case of the auto-scaling solution, like I said, we're going to leverage the ELB service. And we're going to create what's called the load balancer sandwich, where we have an internal ELB, which can be the classic load balancer from AWS or the new application load balancer. And that's going to be responsible for balancing across an auto-scale, in this case, web farm or some other application. But we want another layer for security, and we want that to be able to scale independently. We don't want to have to add a firewall necessarily every time we add a server. That could be cost prohibitive. So we're going to have an external load balancer that's just going to balance traffic across the firewalls that are themselves auto-scaling. So the services that we use are both AWS native services I mentioned earlier, but also Palo Alto Networks services. So we use on the left the CloudFormation template as a way to implement the entire solution. And so all of the components that are required for the solution can actually be defined in a template, including our firewalls themselves. We leverage S3 for things like bootstrapping, which is a great feature in PanOS, where a firewall can be booted with a bootstrap config and come up fully configured and ready to handle traffic without any manual intervention. CloudWatch is kind of the traffic cop behind the scenes. It's the brains for auto-scaling, where it's collecting metrics from multiple sources, and it's making intelligent decisions about when to add and remove compute. Lambda is a service where in AWS you can actually create things like Python scripts that leverage our API or the AWS API, but they can be implemented as a service in Lambda so that you don't have to deploy and manage worker nodes or separate platforms that have to be patched, and you have to consider high availability. Lambda does all that for you. And the autoscale groups themselves are the the logical definition of a group of firewalls or a group of application servers that will scale based on different metrics and thresholds. And then on the right-hand side, bootstrapping I mentioned, where we can actually fully automate the configuration of a brand new firewall so that every firewall that comes up with an auto-scaling group comes up with the exact same predefined configuration. This solution leverages our API so that we can do things like create custom metrics. So a Lambda function can pull our firewall, collect a metric like the number of sessions, and if we feel like that number is getting above a threshold, we'll send those metrics to CloudWatch, which will make an auto-scaling decision. And then Panorama is optional, but it's very useful here because from one Panorama, we can manage all of these firewalls, and in fact, as part of bootstrapping, we can automatically add those new firewalls that are scaling on demand into Panorama so that we can actually manage the security policy in Panorama. And anytime we make a change in Panorama to, let's say, a security policy, not only does that get pushed automatically to all the existing firewalls, it'll show up on all new firewalls as well. So the way it looks in the actual topology is, like I said, we have a CloudFormation template, and that's going to push the base topology, which in this case is the VPC, multiple availability zones, your two different tiers. So we have the web tier, we have the firewall tier, and it even sets up the load balancers themselves. So all this is defined in the template. What we're also going to do, again, using bootstrapping, is we're going to add the initial firewall footprint into these auto-scaling groups. And because bootstrapping can add this to Panorama, if we're using Panorama, they'll automatically be added, and any Panorama device group config will be pushed to those new firewalls. So let's say that we have a case where we need to scale the web farm. That's a built-in service that's native to AWS. So the firewall, or I'm sorry, the web servers they have standard metrics, EC2 metrics. They're sent to CloudWatch. And if it hits a threshold, it triggers an alarm, and we'll add new web servers or app servers as needed. But in addition to that, we can also create a Lambda function, as I mentioned earlier, to monitor our metrics. So via our API, collect those metrics, push them to CloudWatch as custom metrics, and based on different definitions of thresholds, we can automatically add more firewalls in the auto-scaling group, again, independently of the other tier. And again, bootstrapping is still relevant here, so these are being added. If the auto-scale group needs to shrink, not only are we going to remove them, so you're not paying for them, we're also going to unregister them from Panorama, so they're not hanging around in Panorama, cluttering your config or adding to your license maximum. So that's kind of visually what the whole auto-scaling solution looks like. The last piece is, in the case where the internal load balancer, sometimes the VIP will change because the load balancer itself is having a scale up or scale down event. We'll monitor for that and make sure that we have compute from a security perspective to deal with that new virtual IP. So we're monitoring if there's multiple VIPs. If the VIPs go away, we'll remove the auto-scale group automatically. Again, you're not paying for resources that you don't need. So, in summary, so this solution, again, will scale based on your requirements up. It'll also scale down, or I should say scale out and scale in. But we did it in a way where we're leveraging the AWS services because they're already built in. AWS takes care of the redundancy and the compute required to make sure that they're performing. So we're going to use them rather than recreate them and have to create a whole separate management and high availability and all that. So we get real-time or near real-time scalability without having to sacrifice on cost, and we can take advantage of that. So regarding the licenses, generally speaking, we have multiple license options, but in this solution, because these firewalls are transient, just like the other tier, they come and they go, we're going to leverage the pay-as-you-go or pay-go licenses so that you're not spending money on licenses, what we would call perpetual licenses that are only going to be around for a short time. And you can also get more cost savings by, if you know, for example, that your deployment is going to have 2 availability zones and there will always be 1 firewall per availability zone, you can, in AWS, pre-purchase an annual subscription, and AWS will intelligently apply that to that minimum footprint. So if I purchase 2 licenses, those will be at a significantly discounted rate. And as the firewalls come and go, as long as there's 2 or more firewalls, I will always get that discount.
So as a reminder, what we're talking about here is the pay-as-you-go is the VM-Series available directly from Amazon Web Services Marketplace. So it's the firewall VM-Series on demand, if you will.
Thanks, Matt. Okay, so that's the end of the auto-scaling solution. We're going to hold off on answering questions to the end of the call, but I do want to talk about another architecture called the Firewall Services VPC. And then at the end, we'll answer questions on both topologies. So this one specifically, hybrid cloud. So it's a very common use case. In this example that's shown, there's a private data center on the left. There's a VPC or virtual private cloud on the right. And there's some kind of connectivity. Could be direct connect or VPN over the internet. And to secure traffic, we're going to put in a firewall, but we want redundancy. So we're going to have 2 AZs, and we're going to add another firewall. So this is specifically for the hybrid use case, as opposed to the internet-facing auto-scaling use case that we just previously talked about. So that's 2 firewalls for 1 VPC, but as is common for most companies, there may be multiple VPCs, one for department, and that can quickly propagate to be a little unmanageable. So in this example, marketing, they want a VPC, dev, HR, they all want their own VPC, but without having a better solution, we need to add firewalls everywhere and trust that these departments are deploying them correctly, or ask them for access to their VPCs so that the security department can install them correctly. And this gets to be not only expensive, but very difficult to manage. So they can propagate and really get out of control. So we need a better answer for lots of VPCs. We have customers that use dozens or even hundreds of VPCs. So the solution here is, I think it went forward too many. No, I guess not. Okay. Let me get back to where I was. Okay. So we want a way to do central management or central enforcement so that any traffic in and out of the corporate infrastructure goes through a minimal number of firewalls required and are managed by the security department of the company, not having to trust each department to do it themselves. So we want to not restrict them from creating VPCs because that's beneficial. They can do projects much quicker, but we want it to be secure coming back to corporate. At the same time, it would be ideal if all the traffic that's coming out of these servers in all these VPCs to do things like software updates in the middle of the night, it'd be ideal if those didn't have to all come back to the private enterprise, because that means that you have to scale that link for kind of a worst case scenario for downloading lots of images or software updates. So the ideal solution is what's called the Services VPC Architecture. And this is an architecture that AWS has documented and publicized, and we're leveraging. And what it does is normally you can't transit route traffic through VPCs. You can only peer between 2 VPCs. But by creating an overlay network, you can actually get around this. And so what AWS has designed in this architecture is using a services VPC on the left and a subscribing VPC on the right. The little lock icon on the right-hand VPC is the Virtual Private Gateway, or VGW. And it can actually terminate IPsec tunnels to, in this case, VM-Series firewalls on the left and peer BGP information. So now we can actually get traffic and force it through the firewalls without having to have the firewalls in every VPC. So as we start to scale that, we can now have multiple VPCs behind a single pair of firewalls, And even traffic between the VPCs is going through those firewalls. So we have a form of segmentation within the cloud, as well as security going back to the private data center. So if we add back the private data center connection, we have redundant links from the private cloud into the public cloud. And again, anytime a VPC needs an outbound connection into the private data center, or if we're routing traffic from within the private data center to manage those devices on the virtual private cloud, they go through the firewalls that, again, are centrally managed and owned by the security group. If we had an application, let's say that top subscribing VPC actually has an internet-facing application, we can secure that to the internet with its own firewalls and treat it kind of like a DMZ. And we could even do an auto-scaling solution that I talked about earlier, laid on top of this topology. The way the routing works is the firewalls that are booted in the services VPC will automatically learn a default route via DHCP on the data plane, or the Ethernet 1.1 interface. In addition, we can use dynamic routing or define a static route for the enterprise network on those firewalls. And because we have a BGP relationship with the virtual private gateways in each VPC, we can redistribute those routes, the default route and the enterprise routes, into each of the VPCs. And the VGW at that location propagates that in the local route table. So now that default route and that corporate route are learned in every VPC. And so whenever one of those servers is receiving management traffic or needs to reach out and do an update to a Microsoft server or a Linux server, it'll go through that VPC via the routing. In addition, if traffic is coming inbound from the internet, we can do SourceNet on the internet-facing firewalls for that internet-facing application so that we get symmetric routing going through those firewalls as well. So this scales up. We can do services VPC in every region, and we can have multiple subscribing VPCs behind it. But there is a limitation. You'll get to a point where the virtual private gateways, as you deploy them in each VPC, they draw on a pool of subnets that are dictated for creating that overlay IPsec network. And that pool is a limited pool, and after a certain amount of time, the subnets will start to collide. And so things start to get tricky with routing and duplicate interface IPs. So we need a better solution for larger scale. So there are several options. One of them is you could actually add more VM-Series firewalls, or you could add something with VRF support, like open source or third-party vendor router that can do VRF and BGP to terminate the duplicate networks. It's cleaner to do multiple firewalls, but you could also do multiple virtual routers if they don't have VRF support. Doing a VM-Series pair of firewalls per n number of VPCs is the easiest way to do it from a management standpoint. It also gives you more scale for performance as well. And if you really want to get crazy in your scale, we have a customer, like I mentioned earlier, that's doing hundreds of VPCs. And so what they've actually done is deploy physical firewalls in the AWS Direct Connect location, and they terminate their Direct Connect links on the physical firewalls, like in this case, a pair of PA5000s. And now, because it's a Direct Connect location, you don't have the transit limitation from AWS, and you don't need the IPsec tunnels. All you do is BGP peering to each VPC, and you can scale truly large. So the box in the center is representing the Direct Connect location. We're going to put a couple of physical firewalls. We're going to terminate our service provider links, MPLS, or whatever that link may be. And then we're just going to peer directly to, as I mentioned, hundreds of virtual private clouds. So this is a scale graph, kind of just showing the relative cost and scale of each of the options. For most people, you may not need to even go beyond the first pair of virtual firewalls because you're going to do one of these per region. but on the outside chance that you need very large scale, there's other options as well.
Wonderful. Okay. Cool. Thank you, Warby. So we have some questions that's come in, some very good questions. Let's start with the first come, first serve. So can we specify a template stack in the boot files within S3, in the S3?
A template stack in the boot files.
Perhaps the person asking the question, are you referring to a VM-Series policy, perhaps, that in the Bootstrap file? If so, please clarify in the question box.
Yeah, if you're talking about template stacking from Panorama, then absolutely this would work. And the way that would work is in the Bootstrap file, you would configure the firewall to automatically be added to Panorama. Right. And the way you do that is you generate a key in Panorama to authorize this to happen, and you define which device group it should be joined. Then in that device group and template, if you're doing template stacking, that will automatically be inherited by the new firewall. So if that's not the question you're looking for, please post again.
Okay, licensing preferences. So the BYOL or the AWS usage-based licensing. For this particular model, for this particular deployment, the autoscaling, the recommended licensing model is the pay-as-you-go from Marketplace. The reason being is that as Warby mentioned, the firewalls are scaling up and scaling down on demand. And that is the recommended licensing choice, and currently the only supported method of licensing for this offering.
Yeah, so you'll save money by doing that. Now, for the services VPC architecture, those firewalls aren't auto-scaling. They're there because the traffic is more consistent, and in that case, BYOL would be a preferred choice.
Okay, so the next question, can you specify the master key in the AWS S3 Boot Files for use of a non-default master key which has to match Panorama? Maybe they meant or use a non-default key.
Yeah, if I understand the question, the answer is yes. So the Bootstrap file is actually generated. We provide samples, but you can actually go into a virtual firewall, fully configure it, including changing the master key, and then export that. That becomes your Bootstrap. So it'll inherit whatever was in the config, including a non-default master key. Now, the way that it joins in Panorama, if you're using Bootstrapping, it actually in Panorama, you're creating a Panorama authorization key. It's different than if you're manually adding it. That becomes the authentication for that new firewall so that it'll join Panorama.
Okay, so long one here. You described leveraging ELB to spread incoming load across the elastically scaled firewalls. Can this support outbound initiated sessions where the client is in the VPC inside the firewall and the server's outside on the internet? If so, how are the outbound flows caused to traverse one of the dynamically instantiated firewalls?
Yeah, so this solution specifically is designed around inbound. In theory, it could be modified. It would require changing the template and some of the scripts, which, by the way, are all published on GitHub and are freely available. I haven't gotten a lot of requests for outbound auto-scaling because that tends to be more consistent traffic-wise. Usually it's inbound because you don't know when your customers are truly going to slam you with traffic. It's an interesting use case, and it's something we could certainly look into, but the template that we published today is for inbound.
Two questions on the presentation. So yes, the presentation should be available when the recording is posted to BrightTalk. In the meantime, you can also see I think it's around a 10-minute lightboard session and demonstration of this presentation on the product page. If you go to aws.paloaltonetworks.com, on the left-hand side, about middle of the page, you'll see a lightboard series where we walk through this architecture and then give you a demonstration for those who missed the first section of the presentation. Moving on, Good questions, folks. Direct connect. So is there a method of having direct connect to AWS with the VM-Series in the AWS VPC and have the traffic flow through the firewall?
Yeah, this one's a little bit tricky. We've run into this a few times. So AWS doesn't give complete control over the route table. So it's not as simple as specifying the next hop of the VM-Series firewall and you've ensured all the traffic will flow through it. So the easiest way to solve this is actually doing an overlay IPsec tunnel. So if you have a direct connect, you could terminate the IPsec tunnel from the private cloud firewall to the VM-Series firewall at the far end, and then all the traffic would route much more cleanly through there. It's more difficult because of the routing limitations of AWS to do it the other way. But a lot of people choose this even without the routing challenges just because between the direct connect termination and your VPC, there's shared infrastructure. And this gives you complete encryption over that shared infrastructure. So we have a lot of, for example, finance customers that do that as by policy anyway.
Okay, so can you clarify what you meant by IP limitations with many VPCs?
Yeah, so the VPN, the IPsec tunnel between the services VPC firewall, which was kind of in the center of that diagram, and the virtual private gateway, which was that lock icon on the left of all the subscribing VPCs, those tunnels are actually defined by AWS. So when I go into a VPC and I say add a VGW, it'll say download config, and here's the subnet that I'm giving you. You can't configure that subnet, and the subnet is chosen out of a range of possible subnets that has a limit. So after a certain point, it's going to start giving you subnets that are exactly the same as what it already gave you. Now, if you were terminating those tunnels somewhere else, that'd be fine, but because they're all coming back to the same services VPC, you now have duplicate subnets that are dictated from the VGW, as well as duplicate IPs on both ends. So that's where the alternate solutions come up, including multiple VM-Series firewalls.
Can the services VPC architecture operate across AZs?
Yeah, absolutely. In fact, what I was trying to show in the diagram where both the services VPC and the subscribing VPCs were all dual AZ. And it could even be 3 AZs depending on how you want to do your architecture. So I would say not only can it, but it should.
There was a second part to that viewer's question, and that was around Panorama. Panorama is not available in AWS currently. It is only on premises currently, but you can still manage your VM-Series deployments in AWS alongside your physical firewalls. We are working on getting Panorama into AWS, but no definitive timeframes yet. I think this is the other next one is a clarification of the question below. Before previously, you could only specify a template, not a template stack, in the initial configuration file in S3.
Yeah, this is the bootstrapping question. I believe in 7.1, if you have the template stack in Panorama and then you add the firewall to it, it should work, but I would have to verify that. So we can do a follow-up later and make sure.
Can we automate BGP VPN tunnel creations using bootstrapping or in the VM-Series?
Yeah, it's something that we're looking into. So we do have like large-scale VPN. We can bring up multiple VPNs very quickly. We're PAN-OS on both ends. That's actually a very simple problem to solve, and we solved that many versions ago. But because the VGW is creating these on the fly at the time, we don't have a way of programmatically knowing what they are. So we're looking at scripting that. It's turning out to be very challenging because we have to use the AWS API to launch it, then use the AWS API to query for it, and then use scripting to create a config that matches what was given to us. So it is something that we are hoping to do if we can get through some roadblocks, but today we don't have a script that solves this.
In the services VPC model, how does autoscaling work, and does it only work for Palo Alto Networks as an explicit proxy?
Yeah, so two things there. So what I was trying to cover earlier in the services VPC is you could have autoscaling for the internet source traffic, which in my example was the upper right subscribing VPC. So that would be inbound only traffic, auto-scaling to deal with daily or monthly fluctuations coming into an application. The services VPC, where the firewalls are located, those do not auto-scale today for much the same reasons that we just talked about of how do you automate creating VPNs and BGP on the fly when you don't have control over the config. So that piece doesn't auto-scale, but that piece, as I mentioned, is also more managed in that you understand the traffic patterns. And it's not going to change significantly because somebody tweeted the URL for your app, like your internet-facing application. So that's where the focus has been for auto-scaling.
Last question. How does the BYOL model interact with reserved instance pricing on AWS?
Yeah, so the BYOL model is, if you were to go to the marketplace and you were to look at one of our firewalls, you're going to have an EC2 usage cost and you're going to have a software cost. And those are actually detailed what the two are. If you buy BYOL, you basically are removing the subscription part, the software part of that, but you still have the EC2 usage. So if you were going to do, like, let's say a C4 extra large instance, you can do reserved instance pricing for the C4 extra large so that you're getting a discount for the EC2 portion of that cost, and then you can apply a BYOL, so there's no monthly or hourly, rather, software cost. You just have a one-time BYOL license cost.
For the VM-Series.
For the VM-Series. So those two will work together.
Yeah. What are the what are some of the things that you can automate in the VM-Series on AWS?
Yeah. So first of all, the VM-Series firewall is 99% the same code as our physical firewall. So all the automation tools that you get with any of our firewalls are applicable, and the VM-Series firewall is the same in all of our environments. So AWS or other virtual firewall hypervisors, you can do things like dynamic address groups, where you can automate using tags the addition and removal of new compute that you're protecting, so you don't have to constantly change your security policy as the back-end compute scales. Our API is the same, so anything that you want to do custom with our API to automate different common tasks, 100% applicable with the VM-Series and AWS. And also using Panorama, not only can you automate tasks, but you can automate them at scale across many firewalls. Again, it's the same API, it's the same code, so you can do the same bootstrapping, all those different automation features.
Is there a way to do transitive traffic through from HQ through the VM-Series to VPCs without IPsec tunnels, or are they required?
So right now, today, AWS has that transit limitation. So if I have 3 VPCs and I send a packet that's going from VPC A to VPC C, but I tell it to go to B first, as soon as that packet shows up at the boundary of B, it's going to be dropped because the destination IP does not match the address space for that VPC. The way we get around that is with the overlay networks, because now the destination IP is the IPsec tunnel termination point. So our preference would be to not require the IPsec, but for now, AWS doesn't have another solution yet. All the solutions they have are some form of overlay network, such as the one that we presented here.
There's a tagging question. When will we support more than 5 tags per EC2 instance? I believe there's a feature request for that.
Yeah, there is a feature request. I don't have the exact timing. If that's critical for your deployment, we can set up a roadmap call with your sales team. But yeah, it is something that we're looking into. Yeah. I agree 5 is not enough.
Yep. So we're working on it. For more information, reach out to your local sales team and have them set up a conversation with someone on the product management side. Good questions, folks. We'll wait just a second more for the last one to come in, but this is a very good set of questions. To the viewer who mentioned the lack of preparation, yes, we apologize. But I think that we came out on the better side of things. Looks like all the questions are done. This is going to be posted for archival purposes. We thank you for taking 45 minutes of your day to listen to our presentation. Hopefully it was educational. With that, we're going to end the presentation. Take care, everybody.